friends, today I'm starting JEE Toppers file series. This is the first video. In every video, I'll share one trait of toppers that made them top. I have observed these traits in large number of toppers in my long career as a JEE and NEET mentor. In every video, I'll also share one very important concept or question which is evergreen for these competitions. So the first and the most important trait of all the toppers has been consistency. Yes, their consistency. Consistency in JEE and NEET means building a routine of daily learning and practice. And it results in improving memory, reducing stress, ensuring complete coverage, and multiplying the progress. In today's important concepts, I'm revealing through a question. This concept has always been very important and is still very, very important. Look at the question. There is a rod of mass M and length L. It's lying on a horizontal floor. And there is a rod of mass M and length L. It's lying on a horizontal floor like this, on a horizontal smooth floor. Now, this is imparted a momentum P at one end, the end is P and Q. So at the end Q, it is imparted a momentum P. It's like this, see, in this way. It's imparted a momentum P. Now the question is, what will become the kinetic energy of the rod immediately after receiving the impulse? Immediately after receiving the impulse, what will become the kinetic energy of the rod? So here we are applying the law of conservation of energy, law of conservation of angular momentum. You see, we have to calculate kinetic energy of the rod. So the motion of the rod will start like this. It will move in this way. So immediately after receiving the impulse, the center of mass of the rod will start moving with the velocity Vc is equal to P upon M. So the concept becomes what? On a rigid body lying on a smooth floor, at whatever point you impart an impulse, आप किसी भी पॉइंट पे इम्पल्स इंपार्ट करते हो, वो सेंटर ऑफ मास वाले पॉइंट पे आपने इम्पल्स इंपार्ट किया या आपने सेंटर ऑफ मास वाले पॉइंट पे नहीं किया, कहीं और इम्पल्स इंपार्ट किया, तो भी जो सेंटर ऑफ मास की वेलोसिटी है दैट विल बिकम P upon M. This will become velocity of center of mass. Now applying the law of conservation of angular momentum about a point lying on the ground just below the center of mass of the rod. So when I say center of mass of the rod, you can take it for any rigid body. Here it's a rod, so we take it rod. So we are applying the law of conservation of angular momentum about a point on the ground just below the center of mass of the rod. The initial angular momentum is P into L by 2. Momentum of this moment about angular momentum of this moment P about the center of mass is what? P into L by 2. And rod will rotate, begin to rotate like this with an angular velocity omega. So that will become equal to what? I into omega. So P into L by 2 is equal to 1 by 12 ml square into omega. So the omega will become equal to 6P upon ml. This will become the omega 6P upon ml. So the total kinetic energy of translation plus kinetic energy of rotation of the rod will become half m vc square plus half I omega square. So this half m vc square means p square by m square into what? M plus half I is 1 by 12 m l square into omega square is 36 p square divided by m square l square. So now let's simplify. This becomes equal to half p square by m plus This 12, so this 3 by 2, and this will become 1, m will be here, and this will be p square upon what? M. So 3 by 2 p square by m plus half p square by m. This equals to 2p square by m. This is the kinetic energy. This is the kinetic energy. All right. So that means when a rigid body is imparted, rigid body whose axis is not fixed and lying on the ground is imparted in impulse at any point, it will begin to rotate as well as begin to translate. So the velocity of center of mass, you can calculate how the total momentum imparted upon mass of the body. This is the velocity of center of mass. And you can apply the law of conservation of angular momentum about a point on the ground just below the center of mass of the rod. And it's not necessary that law of conservation of angular momentum will be applicable only about that point. You can apply it any other point on the ground, but we are applying about a point just below the center of mass of the rod so that the other calculations, the other part of the calculation will be easier. So that becomes what? It becomes P into L by 2 is the angular momentum of this impulse P about the point just below the center of mass of the rod is equal to I into omega. You got the value of omega. So half mv square plus half I omega square. Now see, students, one more concept that gets cleared from it is what? Because see, at whatever point you impart the impulse, velocity of center of mass will be only this much. But if the point is away from the center of mass, its initial angular momentum will be more. If the point is near the center of mass, initial angular momentum will be what? Less. And so, if the point of impact or the point of imparting impulse is away from the center of mass, its omega will be more, otherwise less. And depending upon that will be the kinetic energy. That means if you want to impart minimum kinetic energy by imparting some impulse, what point should you pick? Is the center of mass. Is that clear? So all right, students, this was the trait and the concept for today's class. So be with me and I'll share with you a lot of such traits which make a topper a topper. And through what kind of questions, that also I'll share in every video. All right, all the best, students.